guys, welcome back to my channel. Today's video will be about Earth, Sun and Moon, and it will be included in this video will be eclipses and moon phases and things related to Earth and Moon. I'll also include some moon facts, but Earth and Sun facts will have to wait a bit. So let's dive right in to see eclipse demonstrations. So I'm going to do a demonstration of eclipses, starting off with the solar eclipse. I myself have never witnessed any eclipse because I haven't. So here's the moon, and this is its shadow, and then just cast the shadow on the Earth. So the places where the shadow is casted, like here is like Canada, here is the UK, here is Europe, and so on. Those places will see the sun covered up for like a while. Some of you might be wondering why solar eclipses don't happen every month, because the moon shouldn't pass in between the Earth and the sun every month. Well, the moon is very far away from the Earth. So and it's a bit tilted, so sometimes it goes above it, which casts no shadow. Sometimes it goes below it, but sometimes at perfect conditions the shadow is casted on the Earth. So some of you might also be wondering, why don't eclipse paths go from east to west instead of west to east? Because the Earth spins east to west, but it's really relying on the moon's orbit around Earth, because the moon is much farther away from the from Earth, meaning that it's much quicker in orbit than the Earth actually is in its rotation. So right now the moon is at its full moon phase. So a lunar eclipse happens when the Earth's shadow hits the moon. So like that. So it's basically like a solar eclipse, but the opposite. And so same reason why it doesn't happen every month, like the solar eclipse. The moon might go up or down. Of course the Earth will orbit its moon, but this is just for demonstrational purposes. So the moon would enter Earth's shadow and then remain in there for a while. It will turn red because of the atmosphere, and it looks really cool. I've never seen it in real life, but I've seen it in pictures. And then it comes out and it returns to its full moon phase. And yeah. So now I'm going to explain 9-10 day. So I've got a lamp here, acting as a sun, and here's the Earth, here's the moon. So because day and night happens because of Earth's rotation on its axis, it spins anti-clockwise, and as it does, part of it goes into the sunlight, faces the sun, and part of it just goes into the nighttime and faces away from the sun. So yeah, that's pretty much a day and night. Rotation on axis. It takes 24 hours for the Earth to rotate once on its axis, and the moon actually takes 28 days, and it also takes 28 days to orbit the Earth, meaning we only see one side of the moon and you never see the other side. So over here is the border, well, yeah, pretty much the border between day and night. So once like countries enter the night, that would be sunrise. On the other side, when they enter the night, that would be sunset. And yeah, that's pretty much day and night. So now I'll be demonstrating seasons. So here's my sun, and here's my Earth. The distances and the sizes are not too accurate, but this is just for demonstration. So some people think we get seasons because the Earth's orbit isn't oval. Then it gets closer at sometimes, making it summer, like oops, and then farther away at sometimes, making it winter. But that's not the case. It isn't an oval orbit, but it's not the reason we get seasons. So the reason we get seasons is because the Earth is tilted at a 23.5 degree angle. So it's spring right now, and the Earth so it's going to be equal day and night. This is known as the spring equinox. Happens every March 20th. Then as the year goes along, the northern hemisphere is tilted towards the sun, making it warmer in the northern hemisphere, making it summer in the northern hemisphere. And then it's winter in the southern hemisphere. It gets to a point where it goes to its closest. It can't go any closer, and the day is the longest. So it's from sunrise to sunset. It's the longest day, and that's known as the summer solstice. And then in the southern hemisphere, it would be the shortest day, sunrise to sunset. Then we go along our orbit, and it's back to being equal distance, which is autumn now. So October 20th is I think it's the autumn equinox. I think that's what it's called. And it's equal day and night again, and autumn starts. And then as we go along, gets winter in the northern hemisphere and summer in the southern hemisphere. And it gets to a point where it's the northern hemisphere is furthest away from the sun, and it can't go any further, like in summer. But this is called the winter equinox, and that's how we get seasons. So I'm going to do the moon phases now, and this is the sun. It's a lamp, but it's acting as the sun. And here's the moon. I put it on the stick so that I can hold it easier. So this would be what a solar eclipse looks like. So the camera's going to be Earth, and this is the moon, and it blocks the sunlight. And yeah, if it's a bit further away from Earth, then the whole sun will not be covered. If it's a bit closer, then the whole sun will be covered. So when it's not fully covered, that's called the annual solar eclipse. When it's fully covered, that's called total eclipse. Sorry, I can't. It's a bit shaky. Anyway, that's a new moon phase, where none of the moon is visible from Earth. Always half the moon is lit up, remember that? And it's the start of the cycle. Then as you progress, this is called the waxing crescent, where very small bits, very slight strip of the moon is visible. The waxing crescent. Then, as we move on, here's the first quarter. It looks like half the moon is visible, and it's around 8 days into the lunar cycle. Then we get to the waxing gibbous stage, where not the whole moon is visible, but nearly all of it's visible. It's called the waxing gibbous. And then we move on to the full moon phase, where the entire moon is lit up and none of it is in shadow. Oh, and if this was a lunar eclipse, then this is what it would look like. So it's entering the Earth's shadow, and it's fully in Earth's shadow. Anyway, let's move on. So that was the full moon phase. Now, slight of it is in shadow. So that's called the waning gibbous. Waning means when it's getting smaller. Then as we move on, this is the half moon phase. Well, yeah, half is visible. This is the third quarter moon phase. And then we get to the waning crescent, where it's about to become a new moon. And that's the last phase of the lunar cycle. And then it gets back to the new moon, and so on. So, the timings of when the moon rises and sets is because it depends on its orbit. So when it's at full moon phase, it's directly opposite the sun, meaning that it rises when the sun sets and sets when the sun rises. But as we have a crescent, it stays with the sun, so it sets shortly after sunset, and then as you progress, it sets later on after sunset till you get to like here, the waning gibbous. It becomes really hard to see it because it becomes visible late night, and at its highest point at around 2 a.m. or something. And then we have the third quarter. That is much more difficult to see, because the highest, when it gets to its highest point at around dawn, and then over here, this is pretty much the hardest. It gets at it. It becomes visible. It's very hard to look at this phase, the waning crescent. I've only looked at it once. So it's visible after sunrise for a while, and then it just becomes, the sky becomes too bright to see it. And that's moon phases. So now it is time for some moon facts. I'm going to give 5 very interesting facts about the moon. Fact number 1. There are earthquakes on the moon. Well, moonquakes. Fact number 2. Eclipses are possible. Solar eclipses are possible because of the size and distance of the moon from Earth. Even though the moon is 400 times smaller than the sun, it is also 400 times larger. I mean, closer, yeah, 400 times closer. So that's how the moon covers up the entire sun during eclipses. And in a few 100 million years, solar eclipses will not be possible anymore, because the moon will move a bit farther away from Earth, and it is 2 centimeters. So it goes further away from Earth 2 centimeters a year. So in millions of years later, the eclipses won't be possible because the moon will be too far away from Earth to cover up the entire sun. Fact number 3. If dinosaurs had telescopes, then they would be able to see the moon, the volcanoes on the moon. Fact number 4. The moon has an effect on Earth's tide with its gravitational force, and that's how tides come. Fact number 5. The moon is the 5th largest natural satellite in the solar system, after Jupiter's and Saturn's biggest moons. So we have reached the end of the video, and thanks so much for watching, and please subscribe. I've seen that 80% of my viewers are not subscribed, so please subscribe, and please like this video and share this video, and stay tuned, and goodbye for now.